This is a new section on conditional probability. Sometimes we're interested in the probability of one event given that a second event has occurred. Three quick examples in meteorology. The probability it rains tomorrow will change given that it is raining today. Rainy days and sunny days tend to come in streaks, and the probability it will rain tomorrow will be affected by whether or not it's raining today. Likewise, the probability of the Dow Jones Industrial Average increases today, that will be affected by the fact that it dropped yesterday. In genetics, the probability a son goes bald given the maternal grandfather is bald, and that extra information affects the probability. So the example we have here is toss a fair die and observe the number of spots on the up face. Let the event A correspond to tossing a 1, 2, or 3. Let the event B correspond to tossing an even number. What is the probability of A given that B has occurred? So we can begin here by drawing a Venn diagram. And here is the event A, and here is the event B. First of all, A corresponds to tossing a 1, 2, or 3, and since B is an even number, the 2 certainly goes in there, and the 1 and the 3 go out here. So that takes care of 1, 2, and 3, and the event A. What is in B? What other even numbers are out there? There is 4 and there's 6, and then 5 doesn't really fit into any of these. So now, if we want to calculate the probability of A occurring given B has occurred, that's the way it's written. This bar here is read given. If you want that probability, what you're now doing is you're saying that the sample space, which used to be this rectangle, is now being reduced to this circle B because you know that B has occurred. So it's basically like rolling a fair die. I'm going to tell you that it's an even number, and now the question is, what's the probability that it's a 2? Well, there are 3 equally likely outcomes now, namely 2, 4, and 6, and only one of those corresponds to rolling a 2, so the probability is 1/3. The probability of A given B is different from the probability of A because the knowledge of B changes the probability.